Okay, so this is just going to tell you the difference between distance and displacement, okay? So first of all, distance is a scalar. It has a magnitude and a unit. So a magnitude is basically a size. So if I look at this distance here, its magnitude is 5 and its unit is the meter, okay? So that is a distance, 5 meters. A displacement, it is also measured in meters and it also has a magnitude. In this example here, it would be 5. However, displacement is known as a vector because it also has a direction, and I will show you in this example what I mean by that. So here we have, so say we said this was a diagram of somebody walking from A to B and then from B to C. If I was going to ask what is the distance travelled from A to B to C, the simple answer is just adding on the magnitudes together. So they're both meters, so we can just add them on. So my distance from A to C, I'm going to add my distance from A to B, which is 5, and add that on to the distance from B to C, which is 10. So my distance from A to B to C is 15 meters. Sorry, that's 5. So that is, the magnitude is 15 and the unit is meters, so that is our scalar because it's distance. If we're looking at displacement, however, that is different. It has a magnitude, a unit and a direction. So whenever I'm looking at displacement, so I'm starting at A and I want to finish at C. So my displacement is simply, just sort of looking at the shortcut path I'm taking here, and this will be my displacement. Now if we look at this triangle, it's not the best drawn, I do apologise, this should be a right angle, and how do we find this sort of hypotenuse? We would use Pythagoras theorem. So to find my displacement of this from A to C, I'm just going to do my Pythagoras, so it's going to be your 10 squared plus 5 squared, so it's 125. However, to find this, we have to square root the 125. So when I square root 125, it is equal to about 11.2 meters. So my displacement, its magnitude is 11.2 meters, and that's its unit as well. Sorry, I keep pointing to the wrong side. However, as I said, it has a direction. Now, most cases, unless it says otherwise, the direction that you want to find is simply an angle, and it is the angle relative to the horizontal position. So here, this is the angle here. There's my horizontal line. That's a 90 degrees. We're ignoring that. It is this angle here. So simply if I look at what I've got here, so this is the distance opposite. So that's my opposite. There's my hypotenuse and there's my adjacent. Now these two here were the given magnitude values. So I'm going to use them to find my angle. So my opposite and my adjacent, if you use your little trigonometry rule, I've used tan. So tan is the opposite over adjacent. So I'm going to do 10 over 5 and I'm going to do shift tan, that's what this is, and it will give me my angle. Sorry. And I get an angle of 63.4 degrees. So overall, I can calculate my distance, it's pretty easy. Displacement is also easy using Pythagoras. And my angle, the direction is simply just the angle relative to the horizontal, which I found using simple trigonometry rules. So that is your answer. Your displacement is your 112 meters, 63.4 degrees from the horizontal position. And my distance from A to B to C is 15 meters.